Rocks. Geologist. Ology means the study of. Geo means earth. So a geologist is someone who studies the earth, in particular rocks. And geologists are known for licking rocks, right? Because different types of rock have characteristic tastes to them. I know, that's right. They've got characteristic tastes. I wouldn't be wanting to licking mudstone though. So, we want to be able to recognise our three main types of rocks. So, sedimentary, igneous and metamorphic rock according to their appearance. Yes, so have you done classification yet in science? No? Haven't done that? Didn't do that last year? Classification? Yeah? Maybe next semester. But we probably won't get to the rock cycle today. We'll just look at types of rocks and we'll spend a few minutes on each type. And this comes out of what's called the Australian Curriculum Standards, ACS. To start with, we're going to look at igneous. Right? Igneous, I-G-N-E-O-U-S, igneous rocks. They begin as magma. Magma, right? Not the same thing as lava, right? They're related, but they're not the same thing. Magma is deep in just underneath the crust of the earth. Yeah? In the mantle, that's right. Magma can form when rock is heated. So magma is molten rock. Molten means liquid. Yeah? If we release pressure on rock, it helps it go into a liquid. When rock is heated, we melt it. And when rock changes its composition, it can go into magma as well. Question?
Wait, so igneous rock is a rock that has been changed by intense heat pressure?
No, it's not. We'll get to that. I said it's formed from rock being heated, not from heat, not from pressure. Pressure released rather than applied pressure. Magma solidifies or freezes between 700 and 1200 degrees. So really hot. It's a mixture of many chemicals which crystallize into a variety of minerals. I wouldn't worry too much about that. Simply, the important thing is magma is molten rock. So magma's molten rock. It's called lava when it reaches the surface. So magma's molten or liquid rock, and it becomes lava when that liquid rock reaches the surface, like in a volcano or in a fault line and so on. We've got a couple of different types of igneous rocks. So if we want to take some notes, we might start off with igneous is molten rock, which is called magma. And if you want, we can branch off. It's called lava when it reaches the surface. Okay, that's what I would write. First type, igneous rock. We have grain. We have what's called coarse grain. Anyone played or used sandpaper before? Yeah? Notice how you've got coarse grain sandpaper and fine grain sandpaper. What does that mean? Or the grit. About the grit of sandpaper. Yeah, so coarse grain would be rough. So grain, we have coarse C-O-A-R-S-E, different to a school course, which would be with a U. Coarse grain is called intrusive. Yeah? Intrusive, inside, typically. It's done at higher temperatures, takes a longer time to grow. Typically, it will be formed just under the surface of the crust. We also have what's called fine grain. And this is called extrusive. These are small grains. Small grains because it cools rapidly. So coarse, cool slowly, cool rapidly. Extrusive, think exit, outside on the surface of the earth. If I look at these examples of igneous rock, what can you tell me? I don't know if you can see it. Granite, would you say that is a fine grain or a coarse grain? It's a coarse grain. Rhyolite, is that a fine grain or a coarse grain? It's fine. Gabbro, coarse. Basalt, fine grain. Excellent. Coarse and fine. Right, we talked about intrusive and extrusive, where it's formed. Diamond is not igneous. Okay, here's a quick question. I'm going to pause the recording. Okay, so fine-grained or no grains present extrusive rock. Very rapid cooling, no or small crystals, extrusive. Characteristics. They are hard, they are strong, they have what's called interlocking crystals. Hard, strong, interlocking crystals. Okay. Lots of examples. Basalt, dolerite, granite, scoria, pumice. You might have heard of pumice stone. It's quite airy, very light, low density. Okay. Next type of rock. It's called sedimentary. Sedimentary's got the word sediment in it. What does the word sediment mean? Deposits on the bottom.
Is this a rock? Not a rock.
You could argue that a brick is a rock. Yeah. Sedimentary starts off with erosion and deposition. Deposition means to deposit. Erosion means to break apart, right? So rain will erode mountains and other forms of rock. All those little sediments will wash down through rivers and waterways underneath the surface of the earth into oceans. Then, over time, water evaporates off, more sediments pack on, and it compresses those sediments together. The layers compact and become cemented. So not the same as cement, but as in they cement together. They're formed at or near the Earth's surface and where there is water. There's no heat or pressure involved. So it's sedimentary. So it's from sediments, they erode, deposit, and then cement together as more sediments build up. No heat or pressure. Erode means to break off. So if I take a garden bed and pour lots of water on it, the garden bed will start to break apart and little bits of the garden bed will wash away. That's what it means to erode. So we've been to cliffs, or we've been to the 12 apostles, right? It's down to like 5 apostles now because they're eroding away through waves and rain. Deposit means to put down. So to deposit money in a bank means to put money into your bank account. To deposit sediments means it will drop to the bottom of the still water. We've got this thing called strata, which are the different layers of rock. And stratification is simply the process of which strata form. Anyone been to the Grand Canyon? Grand Canyon, anyone? Anyone been? That's the Grand Canyon. We notice you can see layers within the rock. The lower down, the older the layer. The higher up, the younger the layer. A few different examples. It's what's called clastic, which is fragments of rock cemented together. Breccia. Notice how it's got little chunks cemented together with some sand or mud, compressed over time. It's often made of dead animal or plant material. So things like coal is a sedimentary rock. So over tens of thousands or millions of years, dead animals and plants will decay until there's only the carbon left, and that carbon compresses to give us coal and oil. We can also have minerals crystallizing from solution, things like sandstone. So, sediments fall to the bottom of a water evaporates off, and as more sediments form, compresses those together. So limestone's an example of that. Different examples, and we'll move on. Last one. Metamorphic. Morph means to change. Yeah? Morph means shape. Meta means change. Yeah, nearly finished. Okay, 2 more minutes. This, you asked the question before, it's metamorphic rock that changes with heat and pressure. So we can either start off with an igneous or start off with a sedimentary, apply heat or pressure or both, and we get metamorphic. So what it's doing is it's changing the structure. Yeah? The mineral content remains the same, but the structure of it changes. So coal, when you compress it under large amounts of heat, large amounts of pressure, you get diamond. We've got 2 types of metamorphization. We've got what's called contact. Contact is the boundary between magma and the surrounding rock. Nearly done. So it changes the composition. Hornfels. And then we've got regional formation. So you may not have you looked at tectonic plates before? All right, some of you have looked at tectonic plates. So at the point at which you've got 2 tectonic plates together is where regional metamorphic rock will appear. Like with Igneous, how we've got different grains. In metamorphic, we've got what's called foliated.